mm, making you host.
Okay.
You are you are live now. Okay.
Yeah. Okay. So, hello everyone. In today's session, we will try to make a radar-based system on that will able to detect the very high speed vehicle or even a smaller speed vehicle. It can you might have seen in the Hollywood movie or even in the real life that some police behind the road carry some kind of gun, and using that gun they will able to measure the incoming vehicle speed, and if they are over speeding then they will do fine on that. So how we can make your such system that is portable and that can be attached to the phone and easily able to detect the speed. So let me show you demo how our system will work and how it look. So here is the video of that. Mm, as you can see my screen. So this is how our system look. So here you can see this is our radar that you can mount on tripod or even on your phone back, and then using this radar it will measure the incoming vehicle speed, and it will give you the real time speed on the phone connected wirelessly over the Wi-Fi, and you can set the threshold speed here in the application like this. Here in the application, in this part of in this part you will set the threshold speed. So if you set the threshold speed to 50 kilometer, 10 kilometer, then if that speed got limited, if that vehicle cross that speed limit, then it will give you the alert and you can do the charge fine whatever you think you can do. It can also be used for measuring the speed of runners in the track of people, or during the sprinting, or if there are various different uses that you can use it. So you can use it in personal way, you can use it in your home, you can use it by the police. There are lots of ways you can use it to measure the speed. So this kind of radar, you not need to mount that on the vehicle itself. You just simply put that radar, mount that radar behind beside the road, and then it will able to measure the speed of that vehicle. Okay. So like this, you can simply put this radar like this, and it will give you the real-time data speed, and it can also be connected to the computer or phone, whatever wherever you want to use. If you want to use the computer, then it will give you the data like this, and here in this part you can set the higher speed limit. If that speed exceeded, then it will give you the alert. So let me tell you how this thing work and what are the components needed to make this radar, and this radar can be mounted on the camera as well like this. Okay, attached to the camera, or it can be attached to the tripod like this. Okay. So let me tell you how this system works and what are the components we needed. So for making this kind of system, the high speed radar that can measure the incoming vehicle, or running people on the road running or whatever the thing have, they can able to measure the speed. To make that such radar, we are going to use the a microwave Doppler radar, and this is the radar that I am using. Okay, and this radar name is HB100. So you can search it on the internet. You will get this radar in the cost of very low cost. It's in the cost of around 150 to 200 rupees, and along with that we want to make it very portable and a small size. So along with that we are going to use this Indus board. Okay, so I am going to use this Indus board. This is Indus board that is very small size. Okay, so this Indus board, okay, this Indus board will connect to this one, to this radar, and it can easily mount over it, and in very small space, very small this size of a space, your device will be ready. Okay, so we are going to use the Indus board and then HB100 radar, and this radar signal need to be amplified. So we also need a one amplifier, signal amplifier. Okay, one signal amplifier like this. So you also need to use the one signal amplifier like this. Okay, so let me show you how this Doppler radar works. So it works on the Doppler effect. You might have read about the Doppler effect, where something is passing by, the things got compressed, and when something going away, then the air got decompressed. Same happens if there is any wave which emitting, and then if that something is coming so closer at very high speed, then the compression will be very high, and if it going away from that data speed, and then again the Doppler effect will happen, and it will go decompression will be high. So it's work on that. So this radar, the microwave radar, what will happen? This microwave radar will send and receive the microwave signals, and when some vehicle or some people coming very fast speed in front of or even the side of radar, then the Doppler effect will happen, and then the signal compression and decompression will be happen, and it will measure the speed using that. Okay, by amplifying the formula. So this is the microwave radar that we are going to use, HB100 microwave. This one you will get it into 100 or 150 rupees. This one HB100. This one. I have told you, you will get around 187 to 200 or even 150 rupees. Maximum is 200. Under the 200, you will get this radar very cheap. And then another thing you need is the amplifier module that will cost you again 10 to 20 rupees like this. And then again you need a one this one Indus board for that will give you the data over the Wi-Fi and do all the calculation and get that, convert that radar signal into the speed. Okay, so you need the Indus board. So overall total product cost will be around 1,500 rupees, something like that. Okay, not more than 1,500 or 1,600 rupees. Okay, so including the Indus board. So you can buy this whole thing from us, or you can get all these components anywhere on the online store. You can search it online. Okay, so these are the components that we need. One amplifier module, signal amplifier module. Another one is the HB100 module, and then the Indus board coil. Okay, yes. Okay, so these are the components that we need, and we are using Indus board coil because it has the Wi-Fi capability, and also it's a small size, so it can totally fit into the very small package like this. Okay, very small package, and become the portable. Otherwise, it will become big size. Okay, that is not portable and feasible. Okay. Okay. Now let's see the radar data sheet. What are the pins that it has? So as you can see here in the data sheet, as you can see here in the data sheet of the radar. So this is the radar, and these are the pinouts of the radar. So you will get one 5-volt and ground pin. So this 5-volt and ground pin are the power line pin, and then you have the pin IF, and again you have one another ground pin. Okay. So these ground you need to sort out, and then using this 5-volt you have to power. So using 5-volt and this ground pin, you will have to. Oh, okay, you have to connect. Okay, and then this IF is the output. It will give you the signal output. Okay, from the radar that is coming. Okay, that is being received from this radar. Okay, so this IF need to be connected with the amplifier module. So here you can see. Here I have the radar. So this is the ground pin, and this is the ground pin. So these two ground pin. Yeah, this is the ground pin, and this is the ground pin. So these two ground pin I have sorted, and then this is the 5-volt pin. That 5-volt pin connect to the amplifier module VCC pin, and the ground pin connect to the amplifier module ground pin, and then there is an analog input pin, the signal input pin on the amplifier module. We have to connect the IF pin, that is the output pin of the radar, to the input pin of the amplifier module. Then again on the amplifier module, you will see the VCC ground and the input and output pin. So input pin is already connected to the radar, and VCC is already connected to the radar 5-volt, and ground is already connected to the ground pin. Now the VCC pin of this module connect to the Indus board of 5-volt pin, that is the V in pin. This V in pin, or 5-volt pin. Okay, and the ground pin connect to the Indus board ground pin, and the V out pin, that is the signal out pin, that the amplified signal pin of this module connect to the any pin of the Indus board. So here I am using the pin number 6. You can connect to the any pin. There are 30 plus GPIO pin on the Indus board. Okay, so here is the total connection of that whole system. So you can see the 5 volt connect to the VCC pin of the amplifier module, and that again that connect to the B in pin, that is the 5 volt pin of the indus board. Okay. And then the ground pin connect to the ground pin of the radar, and this ground pin goes to the indus board. Okay. And then the VIF pin connect to the input pin of the amplifier module, and the amplified signal that amplifier module do amplify is coming on the output pin. So output pin connect to the input pin or any GPIO as an input pin for the indus board, that is pin number 4, 5, 6, any pin. Okay. So after doing all this connection, your connection is ready. Now we need to measure the speed. Okay. So for measuring the speed, and then after doing this connection, you can design your own enclosure and fit it like this in the small package, like this. You can see like this, a small package. Okay, like this. You can cover it, and your radar will be ready for programming. Okay, like this. Okay, you can put it inside the cover. Okay, this kind of cover. Here I have 3D printed the cover. So this is a 3D printed cover on which I can put this radar module. So this is the interfacing pin. Okay, this is the interfacing side. So this side is emitting the waves and receiving the waves. So this is the side where you have to put it. This is the front side. Okay, this side is the front side. This thing you have to mind. Okay, this is the back side. Okay, and this is not doing any kind of sensing. This side is sensing side. Okay. So this side is emitting the signal and receiving the signal. Okay, you can see these tracks out there for this transmitter and receiver. So you have to keep this signal, and you have to, whenever whatever the device you are designing, you have to make that part thin. Okay, whatever cover or case that you are there, make that part thin so that it can able to easily transmit the waves without much loss of the loss. Okay, on noise. Okay, so I have made that part thin, a cavity here, so that easily signal can be transmitted. So I am you can put this into the thin cavity of this radar, and then you can put this here, and then you can on the top of this here, and then you have to solder these pins together, and your device will be ready. Okay, device will be ready. Okay. So after doing this, all this connection, you can go for the code. So let me open the code. So first make a simple code, then we will make it to the IoT. Okay. Yeah, this is a very simple code. Okay, then we will convert it to the IoT. Very we will wirelessly connect to our phone and give you the real-time data. Okay. So here in code, we have to define the pins on which whatever the pin you are connecting, you can use any pin on the indus board. So here I am connected in the to the pin number 4, the radar output signal pin that is being amplified by the amplifier module to the pin number 4. After connecting that, I have to define some variables. One is the pulse count, then last minute, and then pulse per second. Okay, these variables. So this pulse count will count out the pulse. This last millisecond will be calculate at what millisecond the whole system is, is calculating the signal. Okay, and then pulse per second is the variable that will store the how much pulse coming each second. Okay, that is the pulse per second. Okay, and then we will create a void setup function where we will set the radar pin, that is the pin number 4, as an input so that it can read out, and it the internally the shift register on the indus board each uh, it's configured to the input. It's configured for taking the signal rather than the output. Okay. After that, we will use the interrupt and check the the interrupt the signal that is coming from from the radar. Okay, and after that we will calculate the pulse each second counted, pulse per count that is coming on the interrupt pin, that is the pin number 4 as an input. Okay, So after getting that pulse count, we will convert that pulse into the speed. You can either set it to the meter per second or kilometer per hour. Okay, or you can use other calculation as well for other like inch per second, meter, inch per kilometer, whatever. But here we are using the standard, that is the meter per second and kilometer per hour. Meter per second is I am using because of for the slower speed like running, and if you want to measure the running speed option in kind of a sprinter or runner, then you can use the meter per second. If you want to measure the very high speed vehicles like a speed of a bullet train, a speed of a car, a speed of the racing car, if Formula One cars, very high speed cars, you want to count, then we need a kilometer per second. Sorry, kilometer per hour. You can also use the kilometer per second if you want to change the calculation. Okay, but here I am using two calculation, meter per second and kilometer per hour. So I have used this formula here, pulse per second into this formula to convert that into the meter per second, and 0.36 for the kilometer per hour. So after implementing the formula, we will get the speed in the meter per second and kilometer per hour. So when I upload this code, it will start giving me the speed and everything. But currently it is giving the speed on the PC. Now we need to connect to the Wi-Fi. Okay, now let's go for the IoT things. How we convert it and take it to the IoT. So this is the IoT part. So in IoT part, we will use the, obviously we are using the Indus board Wi-Fi. Okay. So here you have to select, include the Wi-Fi, and then we are going to TCP server on which it will host a web server and also stream the real-time data to you. So we are going to include this async web server and async TCP server, these two library, and then like earlier we will define the pins and the different variables for storing the speed in kilometer, meter, and then the pulse and the last minute and all those things to variables. Okay. After that, we will start the web server at port 80. You can change it to anyone, but by default, it's better to keep port 80 on which our web server will be hosted. Then we will create a HTML page. This is the HTML page. Okay. This HTML page is just these are the beautification part where we have beautify the page so that it looks beautiful. And here in the HTML page, it will taking the JSON data, that is the what the database JSON format, that will checks the speed that is coming, okay, that is being calculated and transmitted by the Indus board, and that is a speed in meter per second, a speed in kilometer per hour. Okay. And after that, it will update that speed in the real time. Okay. Uh, and in the loop function, we will transfer after calculating the, like earlier, after calculating the speed, we will send that whole values like a speed, pulse, a speed in meter per second, and a speed in kilometer per hour in a string forward, a string JSON. We will transfer the speed in meter per second, meter per kilometer per hour, and the pulse. Okay. And after that, we will send that JSON string into the web server, and in the web server it will run. Okay. So currently whole system in its AP mode. So after uploading the code, when you open the Wi-Fi, you will see the Wi-Fi named Indus mode radar. Okay, or Indus mode speed. Okay, something like that. Okay. When you connect that, and when you open the web browser, you have to search 192.164.8.1, this IP address. After searching this IP address, you can see the speed of the incoming vehicle. Okay. And here you can set the threshold. If the speed, current speed crosses the threshold, then it will give you the alert. Okay. So this is how our whole system will work. You can also mount it on the poles if you are runner, you want to measure the speed of different people, then you can add different radar at different poles, and then to measure the speed of them. Okay. Okay, or you can mount it like this. Okay, and then you can use it, or you can also mount it the phone camera. Sorry, phone back. Okay, like this. So that's all for today. You can get this whole project on the electronics for you in upcoming month. Okay, so you can check out the upcoming magazine of the electronics for you. We'll get the whole project and the data sheet and the whole whole code as well. Okay, if you want to make any more project or want to make any more suggestion on the Indus board, you can ask me right now. Okay, I am waiting few more minutes. If you have any question, any doubt, you can ask me. Uh, Either from this project or even regarding the Indus board or any other project. Okay. So you can send me the question right now. If you are in the Indus board chat group, that is, then you can also ask question. Then I will take the question from there as well, or you can also use the comment section. Okay. So if you have any question, you can ask me. So I'm not getting any question. So okay, thank you everyone. Thank you.